Okay, welcome back students. So in the previous class we shall start the chapter 10 and we shall start the basic part of what? The linked list and how it will working, the static memory allocation and the dynamic memory allocation difference, right? And in the last we study the info and link part, how it will be connected, right? And the available pointer means we study the topic of what? Garbage collection. Okay, I hope you understood clearly, and if you have any doubt you can ask me, right? So in this class we shall start the topic from basic operations on singly linked list. In singly linked list, what are the basic operations? Basic operations in mainly insertion, deletion and traversal. Okay, but in here insertion is also in two parts. Insertion in the beginning and insertion in the end, and delete is also like two same, and traversal is traversal, means we have to be read the element, right? Mainly we have to be study the algorithm of this insertion and deletion and respective program. Okay, you see, in insertion means what? We have to be insert a new node in a linked list. Suppose I show you, this is a start pointer. Okay, this is the node, and I already told you node contain two part. First one is called what? Information, means contain the element with the data type, valid C++ data type, and second part contain what? What contains second part? It is contain the memory address of the next node. Okay, this is called start. And suppose this is the memory address. Suppose these are the element of int data type. Right. So it will contain this memory address 1003. It will contain this memory address 1001. It will contain this 1005, 1007, 1009, and this will contain null because there is no node further that. Okay. So suppose the element will be 12, 13, 14, 15 and 16. This is a, this is a singly linked list. The first one is, I show you because after that we have to be study the algorithm part. That's why I first of all give you the basic logic, basic concept, basic logic of this. If you don't understand the logic, then you will never be understood the algorithm part. Because algorithm is very, we done many algorithm. Algorithm is very, very logical. That's why I first give you the concept. Insertion in the beginning. Beginning means in here. We have to insert a new node in here. Then what will be difference? You see. So this is just list. Okay. Start pointer 1, 2, 3, 4, 5. We have 5 node. Means 5 information and 5 memory address. These are the 5 memory address, right? So first memory address will be stored by start pointer, and this node of memory pointer, or you can tell link also. It contains this memory address, it contains this memory address, it contains this, but this contains null because there is no node after that. So if we add a new node in here, suppose this is a new node, we create a new node. Suppose we give the information 11 and memory address suppose 999. Okay, and this, because when we create a new node, the information part contain an element, but pointer part contain nothing, null, because up to until we add this in the list, this will contain null, because this is a creation of new node. Creation of new node means we have to create a node. This will be the information part contain element, and this is the memory address. But this contain null. Why null? Because it will up to till now we cannot add this part in here. This node will be till now we not adding here this part in here. That's why it will contain null, because this is the independent node. I hope you understood. This will be independent node, means it will not adding in the existing list. That's why it will contain only null part, and this is the element. Now you see, when we add this node at the beginning, then what will happen? When we add this node, you see, this node will be coming. 999 is coming, and this will contain, now this will contain not null, this will contain 1001. Okay, this will contain 1001. Now start will point in where? Previously start is point is here in there, but now your start will be here, means your memory start contain previously memory address is what? 1001. Now it will contain 999, and this will contain previously null, but this will contain 1001, because after adding this part in here, it will be fixed in the list, means it will contain the memory address of next node, and start will contain the very first element of the memory address of very first element. Previously start contain this, now start contain this, and this null will be pointed to now this memory address when we insertion in the beginning. I hope you understood. Okay, but when up to till when we not inserted, then this will be contain null. When it is independent, means it will be up to when it will not be insert added, means insert added same thing in the list. When this node will added in an existing list, it will be the whole structure will be, you see, somehow means variation will be happen. How variation will be happen? Start contain this memory address, very fast element memory address, and this contain the next node memory address. Means this null will be converted to C. Okay. So this is the basic, very easy concept. Now this concept will be, we have to be write this concept through algorithm. Okay. See. If you understood the basic logic, then you easily understood the algorithm. Okay. Okay. In algorithm, you see, first we write ptr is equal start, means we assume start point as a ptr pointer. Okay, after that new ptr. Don't be confused, okay? See properly, you understood easily. Okay, don't be perplexed. New ptr is a new node. If new ptr is equal to null, print no space available, aborting. 6 new ptr info is equal item, means information part contain the main item, and null if start is equal null, then if start is equal null, then start new ptr else save is also a ptr, means pointer. Save is equal start, save is equal start. Okay, this is (11), 12. Start is equal new ptr, Heart and new ptr link will save. Save. Okay. And you see. So first of all, you see, we assume start pointer as a ptr, right? A new node will be a new pointer. If new pointer is equal null, no space available aborting, else new pointer info null. Okay. Okay, you see, I teach you step by step. You just see from the first point. That ptr is equal start means we have to be pointed as start pointer. We have to start as start pointer, right? And we define a new node. We define a new node as a new pointer. If new ptr is equal null, that means suppose there is no space. No space means actually suppose if new ptr is equal null means if new ptr is not existed, means you think some logically, okay? Suppose if new ptr is equal not existent means no space available, aborting. How you insert? If new point node will be not existed, then how you insert a new node? Like that concept, okay? Just you thinking logically. Otherwise, if you create a new pointer, means new node, new ptr info will be item and link will be null. What I will already teach you in some time earlier. Suppose you create a new node, means this part contain info, means also it contain item, and this will be link. And initially it will be what? Null. It will suppose any memory address and it will contain any of the element, right? We take a start as a pointer, a new node as a new pointer. If new ptr is equal null, means we cannot exist. If the new pointer is not existed, means if you don't create a new node, then how you will insert a new node? Okay, means no space, like that. Otherwise, else if you create a new node, if it existed, then new ptr information will be item and new ptr link will be null. Like up to when it is independent. And if start is equal to null, if a list is means what? We have to be add a node in a existing linked list. But if the linked list is suppose this is a linked list, and suppose we create a new node. Okay, suppose 9001, this is a new node we create as a new PTR, and this is a list. Start is equal null means what? Your list will be empty list. Your list will be empty. Then when we add this node in here, means your start will now point to this. This is was new PTR. Your start will point to new PTR. It contains memory address of this, means this is new PTR. Otherwise, if suppose there is this type of list, suppose there is a list containing 1, 2, suppose there is a list and save is equal start, we assume the start pointer as a save. Okay, then start, when we inserted at the beginnings, now start is new PTR, and new PTR link will be save, because save will go to the next pointer. I show you detail. You see, don't be confused. I show you. Suppose, okay. Okay. I erase this part for teaching purpose. I hope you written it. Okay. Okay, see. I just erase for space. Okay. I hope you written it. When we suppose there is a means, I already told you, in algorithm means what? Algorithm means all possible conditions is coming in algorithm. All possible conditions. Suppose linked list is empty, or linked list is all very much of node, means all possible conditions logic will be coming in algorithm, right? We start give the start pointer in PTR, one pointer PTR, okay, and new node is under new PTR. New node is under new PTR. And if new PTR is equal to null, means if new node is not existent, if new node is not existed, then how you insert a new node in the list? Understood? Means if the new node is not created, then how you insert a new node in the list? Right? If new node is not already created, not existent, then how you insert a new node in the list? That's why it is called, if new pointer is equal null, no space available aborting. I mean, this is the first possible condition. I already told you, it means all possible conditions will be coming in algorithm. That's why algorithm is very, very logical. That's why you have to think logically. Then you understood algorithm. None other than you cannot be able to understand algorithm. Means algorithm is the father of program. Program is mainly one way, but algorithm is in many ways. You have to think multi-dimension in algorithm, right? But program is in only one dimension, means we have to fix that type, that this is the node, this type of node is coming. Suppose there is 5 node, 4 node. In programming, we give the mainly one dimension direction, means give all the fixed, fixed concept. But in algorithm, it will be multiple concept in under the algorithm. Means algorithm is the parents of program. You can say like that. Okay. If new PTR is equal null, means if we not create a new node, then how we insert a new node in a linked list? That's why it is no space available aborting. Else, if new node is created, then we create a new node, means this is new PTR, means info part, and link part means link part will be null, info part contain the any item, any element. It means in C++ valid data type, int, character, float, any. Okay. But link part contain the null part. Why null? Because up to till when we not added this node, this will contain null. I already told you, up to when it is independent, up to when it is not added in a existing list, then if the memory, this link part will contain null, and info part contain only item, this is new ptr, right? Okay, up to this I hope you understood. Means in here we create the assume start as a ptr, new node as a new ptr. If new ptr is null, means here and otherwise we create a node. This means if node is not created, this is not created. Not created. Node means not created. Node. In here node is not created. Node is not created. Node, and in here node is created. Okay. Now coming in here, second part. In here you see. If start is equal to null, if start is equal to null, means we create a node, okay, already we create a node, any item, okay, any element, we create a node, and suppose this is a list. This is a list. Okay, we create a node and this is a list. Means your existing linked list has no node, only start pointer. Means your existing linked list has no node. It will be completely null, and this is a node. Then what will happen? Means in this linked list, when we insert the item, means definitely it is beginning, because there is no node, means it will be beginning and same thing, because there is no node, means this like the empty bucket, means empty bucket, if you put a one more water in the bucket, means it is the first and last, you can say like that. Understood? Means it is an empty list and we have to be insert in the beginning, means beginning and the same thing, it is an empty list. Okay, when we insert a node, means info link, suppose this is an item, this memory address, now start will not null, because start will contain, suppose this is a memory address 9001, start will contain 9001, means start will be your new ptr, your start will contain, because this is new ptr, start will new ptr. Understood? I mean these two condition is for if list is existing, linked list is empty. This is for this condition. And last 10 is, see, last 10 number is see. Suppose linked list is not empty. This is the linked list, and we have to be insert this node at the beginning. We have to be insert at the node in the beginning, means your start will now, suppose this is start, and we say like that, start will assume as a save, first of all, okay, save. Okay, now or you can say like that, this is the save, suppose this is a save, this first node is we take as a save, means save will be start, because start will pointing to this node, save. Okay, you just remember, when we insert a new node in the beginning, you see your start will point to here, where new node will be coming in the beginning, your start will be going to, this is a new pointer, new PTR, and new PTR link will going to save. Understood? Means up to when it will not inserted, start will going to go to where? This start will go to save. After new node is inserted, start will, you know, new PTR, and new PTR link will go to the save part. Okay? Again I am say you. When this is the condition of creating new node. If new node is null, it is impossible. Otherwise new node will be created. This is for the empty list, and otherwise if it will be existing, you know, the linked list containing sub node. Means in the beginning inserted, start will be shifted. Initially start will in here, now start pointed to this, and new PTR link will go to the this. Means save means the node, save contain the first node. First node means previously first node, when up to when node is not added. Save contain the first node of up to when node is not added. Okay? Again I am saying the last part. Suppose this is a linked list, this is a list. Okay? This is a start is equal save, start point this. Okay? After adding this, new node will become your start will, now start is equal new PTR, and new PTR link will go to the first node memory address, means save. First node means this is the first node for up until when your new node will be not inserted. Okay? First node means this, not this node. First node means the first node of means the previous list. First node of previous list up to till when, okay, till when it is not added. New node is not added. Okay? So I hope algorithm you understood. Means all possible cases is coming in, all possible conditions is coming in algorithm. Okay? All possible means I again told you, means in algorithm all possible is coming, but in programming we give only one direction. Means programming is, you can say like one dimensional, means only one dimensional, but algorithm is many dimensional. You have to be think all possible conditions, all possible cases, right? And if you any doubt regarding this, you can ask me. So in next class we study the program for this algorithm. Okay? Thank you.